Hello, and a very warm welcome to our today's webinar with Axelent. This time in a completely new format. I'm Patrick, Global Product Manager at Axelent. And next to me, we have Matthias, our safety consultant and a member of our safety team. Next to him, we have Sven, Technical Advisor at Axelent and a former product manager. And Marcel, he's our product director for our impact protection range. Together, we would like to speak about safety in automated warehouses. So if any questions come up in the next couple of minutes, we appreciate those by sending in an email to safety@axelent.com. And as I mentioned before, this webinar is all about safety in automated warehouses. This often feature different types of conveyors with turning and lifting stations, sorting machinery, storage and retrieval machines, also called SR machines, different types of entry and exit stations, packaging machines, AGVs and AMRs, and also manual order picking stations. Most of these features have been around for many years, but AGVs and AMRs are quite new. So they play a major part in the mobile automation part, and especially in the goods-to-person sector. So, Matthias, could you briefly tell us what AGVs and AMRs are and what the difference is between those two and what is meant with goods to person?
Well, AGV stands for Automatic Guided Vehicle, and they are, you could say, industrial trucks that automatically run through a factory along, in former times, often induction cables in the floor, but now they are mostly laser guided, and they bring goods from one point to another, from a warehouse to persons. We should talk about that still. And AMRs are autonomous mobile robots. So you could say that's the next development stage of an AGV. They are even more flexible. They have their own onboard intelligence, finding their ways, and some have also really Cartesian robots on top that can pick things from one location, bring them somewhere else, and drop them in a work position. And both of these systems are involved in what we call goods to person, goods being carried from a warehouse to the person who is to pack them, to specify an order, or to do a job with them. And this saves people from running around a warehouse, wasting a lot of time that could be used efficiently for something else. And the opposite of goods to person is person to goods, which is more the classic way. A person roaming the aisles, picking the materials that he needs and then packing them in boxes. But also in these systems, in a person to goods system, you would also see HGVs and AMRs today, because the person can place what he has picked on a special vehicle for further processing in a different location then.
Thanks for the first definitions into the topic, but let's continue with that. I also mentioned mobile automation before. The opposite of it is the fixed automation. So could you also give us a brief explanation and example of a fixed automation in warehouses, just for a better understanding?
Yes, sure. Fixed automation refers to machinery that is stationary, that cannot roam the factory, like conveyor systems, all different types of conveyor systems, packaging machinery, stretchers, and of course also so-called SR machines, storage and retrieval machines, that run fixed aisles and pick stuff from shelves and bring it to input-output positions. These are referred to as stationary or fixed automation systems. And the main difference being that they cannot roam the factory.
Yeah. So, thanks for that. So Sven, what would you say are the primary safety concerns in automated warehouses, for instance with the SR machines?
I would say crushing and shearing at the entry and exit points, and also the high speed of these vehicles. They are following rails, they're heavy, and you can get seriously crushed.
And do you also see some risks with the conveyor belts?
Yes, there are heavy loads sometimes. Banking up, you can get crushed or sheared. They can also fall off, for example.
Mm.
And there are lifting stations where you can get hurt.
Matthias, you defined the AGVs and AMRs. How do they add to this general risk situation?
But that was risk situations in stationary machinery. Now with HGVs and AMRs, you add something that moves around the factory. So they move around people. Of course, they use sensors so they don't bump into people, but they could. And then also people are moving. So it's a dynamic hazard situation. And another problem that I see is that while people work, they will not naturally pay attention to AGVs and AMRs roaming. So this might bring up additional hazards for people and also disturbs the machinery.
So you mentioned sensors before. What types are used and how do they detect people? Can you
Well,
explain?
the main sensor type that is used is a laser scanner that is usually installed so it looks out from the vehicle at a level of roughly 100 millimeters. And they may have several such sensors on either side so that they can see if something is in the way, objects or detect feet and so on. And for emergency cases where an object gets in their way, many of them also have bumpers that are contact sensitive and stop the vehicle upon impact. And some of the AMRs, they also have vision systems, 3D camera systems that allow them to detect the entire environment, but these are not safety-related video and 3D interpretation systems. They're just for orientation of people. So it's of the area, no? But it's important to understand that all of these systems don't have safe 3D vision. So things can get overlooked. People can get overlooked by these systems.
It sounds like a little problem. So why is that a problem?
These scanners, they scan. These laser scanners, they scan at a height of 100 millimeter, and they can see the legs of people. But when it comes to an outstretched arm, it will be difficult, and you can get clinched or crushed into a fixed environment like shelves or such a things. And also when you lean over the vehicle, the scanner can miss you, and you can get crushed by that reason.
But to crush an arm, you would need a rigid object nearby, right?
Yes. AGVs and AMRs move around, and you can get caught by adjacent hinders like other machinery, and also guard fencing and also rails.
So Matthias, how can safety be achieved then?
Well, actually, what you need in an environment with AGVs and AMRs is a measure of order. It needs to be neat. It's a good idea to separate the passages of those vehicles and where people work and walk. And our impact protection products might be a good choice for that, to separate people and the vehicle traffic. And this is also important to enhance efficiency of operation, because if people walk around AGVs and AMRs, they will stop them more than you really want, because they sense them as objects and have to stop to avoid hazards.
So you mentioned a lot of barriers. Fencing are not an option for that kind of working areas?
Well, fencing is meant to keep people out of hazard areas in automated machinery. stationary automated machinery, fixed automation systems. But this is not what you want here. You don't want people to be completely away from AGVs and AMRs. You want to separate them to a certain extent, but not completely. And also AGVs don't really need fencing because they sense people and stop in time. But at the very extremity of their operating range, to limit their operating range from other factory areas, there you might want fencing. And then this keeps people out that have nothing to do there. And it would also, in emergency situations, be able to hold back an AMR or AGV if the fencing is strong enough from entering an area that it should not enter. But otherwise, I would rather use impact barriers.
Lucky us that we have Marcel here. So Marcel, any ideas on how to handle such situations?
It's very important wherever AGVs or AMRs are unloading or loading, or if they're approaching a charging station that's particularly hazardous, because that final approach, the sensors actually switch off, otherwise it would stop prematurely, that you separate that area completely from people. You don't want free access. It's good practice to put them against a building perimeter, for example, or we recommend the use of what we call awareness barriers.
So, I've never heard of awareness barrier. What's that?
They're a type of barrier that's not designed to restrict access, but they notify you that you're leaving a safe area to a potentially hazardous one, and they can be quite low level as long as they don't represent a trip hazard. And you need to be careful about the placement. You don't want them to interfere with the sensors of AGV or AMRs, because then they'll mess up the operation. So you need to consider where you place them.
And could you think of any other applications for impact protection in automated warehouses?
There's lots. So all of the types of systems these guys have mentioned already, and any other valuable infrastructure. Pallet racking is more than often used. The actual site infrastructure, the assets like the power supplies, any fire systems, sprinkler systems, this kind of thing. And inevitably, no matter how good your automation is, you will need manually operated vehicles as well, be them hand trucks or manually driven forklift trucks. So wherever you have those things operating together, it's always good practice to define pedestrian routes and vehicle routes. And we have the perfect products for that, like our pedestrian barriers, and you can combine them with our impact barriers to do exactly that.
But we all know Axelent is also well known for the machine guarding system X-Guard. So what role do fences play in automated warehouses? Matthias, could you give us an answer?
Well, we talked about fixed automation already. And of course, SR machines are likely the most dangerous. And to separate the loading, unloading, exit, entry stations from the actual SR machine, you need fencing, definitely. You would also need it in some locations around conveyors, particularly lifting stations, turning stations, automatic palletizers, sorters, stretching machines, machines that put plastic ribbons. So all of these can be hazard spots that need fencing.
But to me, this sounds in a way different from fencing around production machines. So why is that?
Yeah, on automatic production machinery, you will be able to more or less shut people out completely. And in warehouses, the loads are moving from one system to another. And sometimes they are quite big, and you need space for them to pass, and there will become large openings simply. The standards EN 619 and EN 528 therefore set a number of pertinent limits to both the maximum sizes of openings and the space that may be left open between goods passing in and out and external guards. The following opening sizes are considered to allow access with the entire body: square or circular openings of 240 mm, horizontal rectangular openings larger than 180 by 300 mm, or vertical rectangular openings larger than 800 by 180 mm. These dimensions are given in a new draft ISO standard, and also in the US and Canadian standards. More than anything else, crashing and shearing must be prevented in automatic warehouses. Here are some limit values. A clearance of 500 mm between moving elements and fixed adjacent objects or guards is generally considered safe. Where arms may be in danger, the safe distance is 120 mm only. Both these values are in harmony with standards and must be considered in many situations occurring in automated warehouses. Think of turning and vertical conveyors, stacking machinery, etc. Shearing and crushing hazards may be considered as avoided if the static force to keep the load stationary or deflected is less than 150 Newton. For clearances from 120 mm to below 500 between conveyed unit, loads and fixed adjacent objects or guards, crashing and shearing points. Different type of safety measures are required.
Matthias, any more ideas to this?
Well, at the entry and exit points of conveyors to a dangerous system, you might also have an inclined guard, 45 degrees inclined in the direction of the goods traveling in. The idea is that this would push an arm away that is maybe held in between there. And then, of course, you always want to look out for those 120 millimeters or the 500 millimeters that Sven already mentioned as safety distances. And there's one more consideration is, believe it or not, some people crawl underneath a conveyor into a hazard zone. And that's possible, as we learned from these dimensions, if a slot more than 240 high is available to do that. So you would have to ensure that such space isn't there, or you could use some mesh or an individual bar to make the slot smaller so that people can't crawl in.
Yeah, and as for the summary, what would you say, how can customers come up with a safe warehouse environment? Maybe you can continue, Matthias.
Well, aside from knowing the standards, the most important thing really is to do proper risk assessment in the planning stage. And that's particularly important if you renovate, if you modernize systems, that you study carefully what you want to do. And don't just focus on hazard situations, on moving parts that can cause danger, but focus on the tasks and the operations. What will people do? What is the job of the machinery? And then try to identify the hazards involved in those tasks and in those operations. And from the standard, select the right type of solution. That's what we use all over in production machinery, task-based risk assessment, and I would also recommend this here.
So Marcel, is there anything you would like to add?
Yeah, I completely agree with Matthias. I think it's a very good idea that wherever you've got any vehicles operating in an automated warehouse, whether they're automated or autonomous or driven by people, you want to try and separate them from pedestrians, create a safe pedestrian area and a clear designated driving area. And in that process, I think it's good to take a risk-based approach. So you can look at what measures you might implement and see how they affect your operations. There's no point creating barriers that people will try and circumvent or really slow down your operations. We're seeing a lot of people using simulations to simulate whole plants, manufacturing processes, etc. And I think we'll see more of that used to look at what pedestrian and vehicle flows, how they operate in a plant before they're actually implemented. And that's a really good approach to take. Thanks.
Sven, do you have anything to add as well?
Yeah, I would like to add that Axelent have the expertise and the products to help plant engineers and designers for their planning work. It's very important to think about safety in an early stage, wherever you are doing, and also when it comes to modernizing or improving your existing facilities and production.
Yeah, many thanks, guys, for that interesting exchange. And yeah, we really hope you enjoyed the webinar to safety in automated warehouses. We wish you now a nice rest of your day. And yeah, as I mentioned before, if you have any questions, please feel free to send them in to safety@axelent.com. Thank you.